Before we start to see the method for solving polynomial inequalities, let's take a minute to see why it works this way. Because this is one of those methods that feels really strange, unless you know why you're making this choice. Now, we made a strange choice when we solved polynomial equations. The best way to solve a polynomial equation is to get it into the form where we have a factored polynomial equal to 0. And the reason that we do that is that if a product is 0, then one of the factors must be 0. So we split it up, we set each factor equal to 0, and each of those gives us a solution. We also have facts about how a product compares to 0. Right? If a number is less than 0, that means it's negative. If a number is greater than 0, that means it's positive. And when we're doing multiplication, it's easy to predict the sign of the product, positive or negative, based on the signs of the factors. So that's what we're going to do to solve a polynomial inequality. Now, in this first example, I'm going to go through all of the gory details of the line of reasoning. And then in the next video, we'll see how we can summarize that in order to be able to work more quickly. So here we're given a polynomial inequality in that form that we want. A factored polynomial on one side and 0 on the other. And here our inequality sign is greater than or equal to, but that actually is only going to matter to us at our very last step. So we'll think about that at the end of the problem. Our first step is to notice that if this were an equation, if we had an equals sign, that equation has two solutions. They are x equals 3 and x equals -1. And notice that if we think of these numbers on a number line, they divide the number line into 3 parts. So we have our two solutions, and then we have the numbers that are to the left of all of them, the numbers that are in between, and the numbers that are to the right of all of them. So what we're going to do is analyze the sign of the product on each of those parts of the number line. So our factors, we have an x minus 3 and an x plus 1. If x is less than -1, then subtracting 3 from both sides, then x minus 3 is less than -1 minus 3, which is definitely a negative number. -4 is less than 0. So this is negative. And x plus 1 is less than -1 plus 1, which equals 0. So x plus 1 is also less than 0. X plus 1 is also negative. And then the product is a negative number times another negative number, and so it's positive. At x equals -1, well then x minus 3 equals -1 minus 3 equals -4. X plus 1 equals -1 plus 1 equals 0. The product is negative 4 times 0 equals 0. Right, we can do that exactly for the one where we know what exact value x is. If x is between negative 1 and 3, then x minus 3 is between negative 1 minus 3 and 3 minus 3. So x minus 3 is between negative 4 and 0, which means that x minus 3 is still negative. On the other hand, x plus 1 is between negative 1 plus 1 and 3 plus 1. So x plus 1 is between 0 and 4, which makes it positive, which means that the product now is a negative times a positive times a positive. So the product now is negative. When x equals 3, well, then x minus 3 equals 3 minus 3 is 0. X plus 1 equals 3 plus 1 is 4. And so the product is 0 times 4 equals 0. And on this last interval then, if x is greater than 3, then x minus 3 is greater than 3 minus 3, which is 0. So x minus 3 is greater than 0. That factor is positive. And x plus 1 is greater than 3 plus 1, which is greater than 0, right? 4 is greater than 0. So x plus 1 is positive. And thus here, the product is a positive times a positive, which is positive. So now we know what the sign of the product is in each part of the number line. Now we look back at the inequality and see the inequality says greater than or equal to 0. So we want to know where the product is positive or 0. So that means, let's see, where is the product positive or 0? Well, here it's positive, here it's 0, here it's 0, here it's positive. We don't want this part, and there the product is negative. Okay, so now we just describe that. We want negative 1 and everything less than it. We want 3 and everything more than it. So we want all of the x's where x is less than negative 1 or equal to negative 1, or x is greater than 3 or equal to 3. There it is in set builder notation, or in interval notation. We have from negative infinity up to negative 1. Negative 1 is included. Union, because there's a gap in our interval. And then 3 is included, and from there to infinity. So set builder notation, interval notation, we're describing the same thing. And what we're describing is just that part of the number line. And looking at that part of the number line, we actually see something that's going to provide a shortcut for solving these sorts of inequalities in the future. Instead of writing out all of these steps of analysis Instead, we're just going to use a number line to analyze our signs and analyze our products.